So when you are going into one depth, okay, one depth at a time, one depth at a time. So you are going in depth. Let's say you are going here again. You are going here again. You are going here. So we are in one depth. We are exploring one depth. So in that, how much depth we have to explore? How much depth we have to go? If we are limiting it, it is called depth limit search. So let's say we are limiting up to 5 depth or 4 depth, then that particular is called depth limit search. So instead of going to the very depth node of the state space diagram, if we are going to the limited depth, that algorithm is called depth limit search. The embarrassing failure of depth first search in infinite state space can be elevated by supplying depth first search with a predetermined depth limit L. That is, node at the depth L are treated as if they are node successor. This approach is called depth limit search. So why it has been limited? The meaning is, instead of going to, let's say, the Bhubaneswar city from the railway station, it is of 16 kilometer of radius. Let's assume that. So if we are assuming 16 kilometer, then to search the friend's house, we have to go up to 16 kilometer. Now what we do is we just limit the depth of 5 kilometer. So we'll go in one path for 5 kilometer. If we are not getting the friend's house, then we'll go back. Again, we'll go to the 5 kilometer to other road. Then go back. Again, we'll go to the other. So in that will what happen is we'll just reducing the time complexity more. But is it a complete solution or completeness is there? So completeness might not be there. Means let's say your friend's house is 6 kilometer from the Bhubaneswar railway station. Then what will happen? Then you will never get the solution with depth limit of 5. So is it complete? The completeness is there in this particular algorithm? No, complete is not there. Is it faster than that? Yes, it is faster than the depth first search, but completeness is not at all there. So the deep depth limit solve the infinite path problem. Unfortunately, it also introduced an additional source of incompleteness. If we choose the length, the limit, which is less than the actual depth. That is, the shallowest goal is beyond the depth limit. This is likely when D is unknown. If D is unknown, then okay, we have taken some L. But if D is known, then it is not a meaning to take L. Depth limit search will also be non-optimal if we choose L, which is greater than. So if it is not optimal, means let's say the radius of Bhubaneswar city from railway station is, let's say, 16 kilometer. And we have taken L, which is L limit or the limit as 22 kilometer. So it is it okay? So it is not giving you the right solution because you will go beyond Bhubaneswar city, right? And it is not optimal. So you have to choose L based on D. If D is not given, then it is very very unpredictable to choose L. Its time complexity is, what is the time complexity here? It is B is the branching factor to the power of L is the limit, is your time complexity. And what is the space complexity? Space complexity order of branching factor into L. Depth first search can be viewed as the special case of depth limit search with L is infinite. If we'll make as L infinite, then it is the depth first search, because we are going to one direction till we'll explore the last leaf node. So we are going to the depth, the limit. Limit is not at all defined in depth first search, but here the limit is defined. The algorithm is written accordingly. So we have to, what is the difference here is, we have the limit here. The limit, we have to go up to the cutoff limit, and then the depth first search, and here also we have to look for the limit. So we have to expand the node till the limit. Okay. Then we have iterative deepening search. So what happened into the iterative deepening search? We are using the deepening search algorithm, but the thing is that will increase the limit value by 1 all the time. Let's say L was 5 previously, and in 5L we are not getting the solution. So we'll increase the L value as 6 and we'll look for the solution. If we are not getting the solution, we'll increase the L value as 7. So as you can see, this particular for loop will go from 0 to infinite. Means it is taking the limit one by one, and it is also at very last it is taking to infinite. It means we can go to the infinite depth, but one limit increasing at a time. So what will happen here is the completeness will be there because we are getting the solution all the time, and the limit is also there. Means we are reducing the space and time complexity as well as it is complete. So iterative deepening is the modified version of the deep limit search, in which we have used the loop in the deep limit search, and we have the limit will go on and on, or will increase the limit by all the time 1 up to infinite till we'll get the solution.